This video is beginning chapter 5. Although we do not study section 5.1, we do want to know the equation of the unit circle. So just the only thing we need from this is an equation of a circle. So the general equation of a circle, if the center is at the origin, is x squared plus y squared equals r squared, where r is the radius and x and y are the points on the circle. Okay, so let's see what this is talking about. The radius in the unit circle, the radius has 1. So if we had our x and y axes, and we went out 1 unit here, that point would be 1, 0. And if we went up 1 unit, that point would be 0, 1. And if we went left 1 unit, that would be negative 1, 0. And then if we went down 1 unit, that would be 0, negative 1. And if we connected those points in a perfect circle, the equation would be x squared plus y squared equals, since my radius is 1, it would be 1 squared, which is 1. So x squared plus y squared equals 1, where the radius is 1. Okay, so any point on the unit circle will be a solution to this equation. So this is my equation on the unit circle. And to point 1, 0, which was the one over here, right here, if I put that into this equation, my x coordinate is 1, my y coordinate is 0, and my radius is 1. So I get 1 squared plus 0 squared equals 1 squared, or 1 equals 1, check. And it would work the same with this one. If my x coordinate was 0, y coordinate was 1, radius is 1, I still get 1 equals 1. It also works with the negative 1, 0, which is this point over here. So if x is negative 1 and y is 0, my radius is 1. A negative 1 squared is a positive 1. And we get, okay, so all of these points work. And here's the point 0, negative 1. And that also works. 0 squared plus negative 1 squared equals 1 squared. Okay, any point on the circle would work. Okay, unfortunately, these are the only 4 points that are integers on the unit circle. Okay, integers are whole numbers, positive and negative whole numbers. The other points we will use extensively will be found in the following sections. Okay, so just to solidify this, if we had a bigger circle with the radius 5, then that would be, this point would be 5, 0. These are the easiest points. These are called the quadrant points. Negative 5, 0, and 0, negative 5. Okay. Then we have, oh, here's this point 0, 5. So we would have x squared plus y squared equals, now what's my radius? 5 squared. And sure enough, we have 25 equals 25. It checks. And how about the point 3, negative 4? Well, that would be over 3 and down 4. Looks like it's right about here. And if that point is on the circle, it will work in this equation. So let's try it. X is 3, y is negative 4, and radius is 5. So we get 9 and 16 equals 25. Ooh, how nice. What about negative 3, negative 4? Sure enough. And any variations of those signs. So that's again 9 plus 16 equals 25. This is called a Pythagorean triple, a 3, 4, and 5, because a squared plus b squared equals c squared from Pythagoras. And the 3, 4, 5 triangle is a very popular right triangle where we have the 3, the 4, and the hypotenuse is the 5. So there's this right here, 3, 4, 5. There's this one up here, which is 3, 4, 5. There'd be this point over here where I'd go -3, +4, right there, and then I would go -3, -4. So there's 4 whole triangles in there. The other popular one has a radius of 13, and it looks like this. This would be 13, 0, 0, 13, -13, 0, and 0, -13. So this circle also has beautiful points. And that would be, well, this, first of all, 13 squared plus 0 squared equals 13 squared. That's easy. But this one has, say, -5 and up to 12. And that's a nice triangle. So let's try -5 squared plus 12 squared equals 13 squared. And you'll get a 25. You can check on your calculator if you like. 12 squared is 144, and 13 squared is 169. And sure enough, this works. This is another Pythagorean triple for all of these, and it's a 5, 12, 13, those 3 numbers. So that means I can go over 5, up 13. There's another one. I can go left 5 and down 13. I can go right 5 and down 13. So those 4 triangles, all Pythagorean triples. So there's the -5 and the -12 one right here. And those would work if we put them in our equation. Oops, -12. And that gives me another 25, 144, 169. Okay, so that's the beginning. And what you're going to need for the next videos is a blank unit circle. So if you can't print this circle out, I'm going to make it small so you can see the whole thing. If you can't print it out, I want you to get a piece of paper and create it along with me. You're going to need to have this. So let's do this. I'm going to take a little break, end this video, and then we'll start the lecture for section 5.2. But you will need your unit circle, blank unit circle, which you see on the left here, to do it. Okay, so go for it.